In the last lecture module, we discussed the classical view of concepts. In this module, we'll turn our attention to the prototype theory of concepts. We'll talk about the nature of conceptual structure within the prototype theory, and specifically that it views conceptual structure in terms of a list of perceptually salient features. We'll talk about the process of categorization within the theory, namely similarity judgments based on feature matching. We'll go through an example to illustrate this using the concept birds. Having explained the process of categorization within prototype theory, we'll be in a position to explain how prototype theory purports to explain typicality effects. We can illustrate this again using that concept of birds. To account for typicality ratings, researchers in the mid-70s began to adopt a different approach to thinking about concepts and conceptual structure, an approach that's often called the similarity or probability view. They hypothesized that people represent concepts not as definitions, but as lists of features. Thus, concepts become fuzzy and exhibit typicality effects. Typicality effects arise in categorization when people compare the object to their stored representation of a concept's features, judging conceptual membership on the basis of a similarity between the object and the concept measured in terms of these features. The basic idea has been cashed out in two ways. Prototype theory presumes people extract a representation of the central tendency from a collection of objects. That is, they form an abstract representation, a summary of the concept by listing perceptually salient features occurring in many but not all instances. Within this summary, relative weighting can be assigned to features. Such representations then are called prototypes. An object is classified as an instance of a prototype if sufficiently similar to that prototype as measured by the number of properties that the prototype and the object share. Similarity of objects to prototypes explains speed of categorization and similar effects. The more properties they share, the quicker the minimal level of matching is met between the object and the prototype, and the quicker the categorization can unfold. The classical theory of concepts supposes that when we possess a concept, we in essence have the formulation of its essential nature. That is, we have a definition in the form of a set of individually necessary and jointly sufficient conditions for membership in that category. And when we categorize that, we're categorizing on the basis of the essential elements that make that thing the kind of thing that it is. Now, this seems like a fantastic theory of concepts and categorizations. However, when we start to observe human behavior, one of the things we notice is that human categorization behavior seems to be strongly driven by accidental and superficial sensory properties of objects and not sensitive to, at least in many cases, their essential nature. And in order to be able to categorize, if you're sensitive to variations in sensory properties, you have to have a certain flexibility in the way that you categorize that allows you to categorize objects that don't share a lot of things in common. So this is beautifully illustrated by that passage from Descartes, where Descartes says that I recognize this stuff as a piece of wax, even though when I first had it, it was a honeycomb and it had a particular scent and shape and coloring and so on, and then it melted and now it has none of those properties at all. That's an extreme version of the sorts of differences and variations that we have to deal with in real-world categorization. Similarity probability theories of concepts and categorizations have both of these features as strengths, precisely because of the way they suppose that concepts are represented and how those representations operate in categorization. So let's take a look at a couple of examples of categorization and the mechanisms associated with prototype theory and how they operate in order to allow for this flexibility and this differentiation in typicality between individual instances of a category. So suppose we see a robin in a visual field. That triggers our categorization mechanisms, and they start to match the features of this robin to features of the various concepts that we have available to us. Since robins are very, very typical instances of the concept of bird, they have all of the properties that people often associate with being a bird. They fly, they sing, they lay eggs, They're relatively small, they nest in trees, they eat insects, they have feathers. Then we can identify this object quite quickly. And we do so then and judge it to be a very typical instance of that category. We use our list of features and we map those features to the features of the object. And once we reach a sufficient number of matches, then we say that it is an instance of that concept. If we get another bird coming into view that's quite different from our robin, it again triggers our categorization mechanisms. Our categorization mechanisms then start to map the features of this bird to our bird concept. But now we're starting to get misses, and it's going to take us longer because we go through flies and sings before we finally get to one that it matches, because penguins, and in this case emperor penguins, lay eggs. They're not small, they don't nest in trees, they don't eat insects, but they do have feathers. And so we get a couple of hits on this, and that allows us to match, but our match is slower, and we judge emperor penguins as less typical than robins of our concept of birds. And so we get increased flexibility in our categorization as a result of the way that concepts get represented in theories like prototype theory. And we get this natural emergence of differentiations in typicality from that very same representation combined with the feature mapping mechanism that underwrites our categorization abilities on these theories. A natural outcome of the interaction between the conceptual structure of prototype theories, namely lists of salient perceptual features, together with the mechanism of categorization, the matching of that list of features to the features of an object, looking for a minimum level of matching similarity, naturally results in a typicality gradient amongst instances of the concept. The more features that an individual instance has, the more typical it is of the concept. So robins, having all of the features, are very typical of our concept of birds on prototype theory. Penguins, having only a few of those features, are far, far away from them on the typicality gradient, at the very edge of the bird concept in the prototype theory. Before leaving our discussion of theories of concepts, I should take time to note that there is no current definitive theory about the structure of concepts. Prototype theory has known weaknesses, such as it incorrectly predicts the typicality of combined concepts from the typicality of constituents. For example, people judge small spoons as more typical than large spoons, and metal spoons as more typical than wooden spoons. This should result in the ordering small metal, small wooden, large metal, and large wooden. However, people judged large wooden spoons to be in the second spot. This lapse in combined typicality, as predicted by typicality of individual properties, is a problem for prototype theory, one of many problems actually. So there isn't a definitive theory. Nevertheless, the phenomenon that drove the formulation of all versions of similarity and probability theories still holds today. Human beings exhibit tremendous flexibility in their categorization behaviors. Their categorization behaviors can account for a wide variety of variations in the individual properties of the objects that they categorize under a single heading. And finally, their categorization behaviors exhibit a pronounced typicality effect over a large swath of concepts. So while we don't have a definitive theory about the nature of concepts, the insights that drove our development of prototype theory and other versions of the similarity probability view still hold true and still drive the underlying dynamics of our lecture.